Shucks! John, I just can't do it.
You're looking flustered out there, Connor. What's going on? Come on.
I can't help it. I'm trying to review for my calc final, and I just don't remember how to graph f of x, f prime of x, and f double prime of x when I'm given one of the graphs.
Come here. I'll show you on the whiteboard. Here we go. So look in here. We have some examples of the graphs of f of x, f prime of x, and f double prime of x. So if you're looking up top at f prime of x, you see that we have here pretty standard upside down parabola. And so when looking at a graph such as this, you really want to take note of where the stationary points are. And so right here we see that there's a local maximum at the point 2, 1, and then there are 2 zeros as well at 1, 0, and 3, 0. And those will come into play when you're drawing your graphs of f of x and then eventually f double prime of x. And so from f prime of x, as this graph is, we can see here this is how it looks as f of x. And so because, of course, f prime of x is a representation of the instantaneous slope of the graph, of course, at 1, 0, you would have to have a stationary point. At 3, 0, you would have to have a stationary point. And then because 2, 0 2, 1 represents the absolute maximum of the graph of f prime of x, you have to have an inflection point, or the point where on f of x the slope is the greatest. So, as we see here, going up to the point 1, 0, the slope is below the instantaneous slope is less than 0. So on f of x, you see that it's coming down here. And then once it hits the point x equals 1, it has to come to a minimum. So it doesn't really matter exactly where, because it could be 1 comma anything. The height could be anything. However, it needs to be the local min there. So then it comes up here, and at the point, so here it's 2 1.5, for example. It represents where the inflection point has to be, where the slope on f of x has to be the greatest. And then we continue on to the point where x equals 3. And once again, we see here that on f prime of x, it's a 0. It's where it crosses the x-axis. And because it's crossing from positive to negative on f prime of x, we know that the slope has to be approaching a local maximum. So on f of x, it goes up, reaches a local max, and then because it's going negative here, the slope then has to be going in a downward trend. And then once again, when you're translating from f prime of x to f double prime of x, you're kind of thinking in the same way. You got to see where the stationary points are and how they're going to come into play. Really, for f double prime of x, you have to look at where the, f prime of x has a local max, or where the instantaneous slope is going to be 0. And so obviously, because at the point x equals 2, there's a local max, that's where the slope is equal to 0 on f prime of x. So on f double prime of x, you're going to have a 0 at x equals 2, so it's going to be 2, 0. So we have that point plotted here, and then because f prime of x is concave down, we're going to have a negative slope going just across the graph there and going through the point 2, 0. Alright, and just to emphasize to you the point that many different graphs can be represented in different ways, we have f prime of x here once again, this upside down parabola. But then, as you can see, f of x looks pretty drastically different. Although, as you can see, there are some similarities. For example, when x equals 1, there is still a local max on f of x. And as well, at x equals 2, there is an inflection point, or the point at which the slope is greatest. And then, as well, at x equals 3, there is once again a local max. However, where these points are in terms of their vertical location can definitely change depending on the equation. And as well, here at f double prime of x, the slope is much steeper going down. However, it's still going down, and it still has a 0 at x equals 2. So just to reinforce the fact that graphs can be drawn when they're being translated between f of x, f prime of x, and f double prime of x. They can be shown in a variety of ways. However, the stationary points and the critical points, really, they are the ones you have to look out for because they'll always pretty much follow the same rules.
Okay, and that's how you do it.
That makes so much sense. Thanks, John.
Oh, yeah. Now go out there and win the game.